So today we're going to be talking about a different form of linear equation. So when you're writing a linear equation, we have slope-intercept form, which is y equals mx plus b, right? That's what we did last week. That's the most common way that you will see a linear equation written. Another form of a linear equation that is actually very user-friendly is point-slope form. Point-slope form is y minus, we call this y1 or y sub 1 equals m times x minus x1. So let's fill in what we know. M stands for what, guys? Slope, so label it. And then y1 and x1 are the y and x coordinates of a point. So x1 is the x coordinate of a point, of a given point. And y1 is the y coordinate. Okay, the x and the y, so just the straight x and y, those stand for any x and any y. So they stay as variables, okay? But the x and the y here are going to actually be coordinates. Now, what do you notice about the x1 and the y1? What's being done to them? They're being subtracted. So when I plug a number in, let's say I plug in the point 1, 1, positive 1, positive 1, the equation is actually going to show that they're being subtracted, right? But we know that we plugged in a positive number. What would happen if I plugged in negative 1, negative 1? What happens to those subtractions? Subtracting a negative turns everything into a positive. And you're going to see this when we actually plug stuff in. What I want you to recognize and remember is that whatever sign is attached to the x1, y1, the actual point will be the opposite. Okay? So subtraction means opposite. So write that down. So that means that we're going to be taking the opposite of whatever is there. Okay? And we'll practice that. You'll get used to it pretty quickly. Okay? So why does this work? We're going to actually prove why this form of the line works, and then we're going to get into some examples. So the proof. We're going to use the definition of slope. To show you why this actually works. What's the definition of slope, or the slope formula? M equals y2 minus y1 over x2 minus x1. Good. So we use y equals, or slope equals y2 minus y1 over x2 minus x1. And then what we're going to do is we're going to let xy be any other point on the line. And we'll substitute xy for x2, y2. So what we're saying here is that instead of picking two specific points, we're going to let one of those coordinates be any x and y, so we just call them xy. So instead of y2 minus y1, we're going to have m equals y minus y1 over x minus x1. So we just substituted x and y in here for the x2, y2. And that is what generalizes this whole thing. So instead of picking a specific point, we're saying just in general. Okay? Now, I want to get this x minus x1 out of the denominator. Right now it's being subtracted or divided. So what's the inverse of division? Multiplication. Multiplication. So we are going to multiply each side by x1, or no, by the denominator, x minus x1 and then simplify. Make sure you put it in parentheses. So watch what happens. If I have m equals y minus y1 over x minus x1, to get x minus x1 out of the denominator, I multiply by x minus x1. And whatever I do to one side, I have to do to the other. When I'm multiplying and dividing by the same quantity, they reduce to 1. So we are left with x minus x1 times m equals y minus y1. Isn't that the same thing that I put up here? I just reordered stuff. Okay, so that's why it works. So basically, point-slope form comes from the definition of slope, the slope equation. Okay? Now I'm going to show you how easy it is to actually utilize point-slope form. So let's look at the first example. So the first example, I am going to give you a point and a slope, and you just have to write the equation that goes through that point with that slope. So on number 1, I give you the point 4,2, and the slope is 3. All we are going to do is plug that stuff into the equation. So that's going to be y minus the y-coordinate of the point, which is 2, equals the slope, 3, times x minus the x-coordinate of the point, which in this case is what? 4. Done. That's really all you have to do. Okay? If I wanted... So, do you guys see what I mean? Let me backtrack. When I say that the coordinate was actually 4, 2, but when we plug it in, it's minus 4, minus 2. So, it's going to be the opposite of what the actual point is. So, let's do number 2 together, and then I'll have you guys do number 3 on your own. So, we have y minus negative 4. So, if I have y minus negative 4, what actually happens? It becomes positive, so I'm going to rewrite it as y plus 4 equals negative 2/3 is your slope, so negative 2/3 times x minus the x-coordinate. What's the x-coordinate? Positive 8, so it's going to be x minus 8. And that's all you have to do. Easy? Okay, do number 3 for me. So, Malika, what did you get for number 3?
Y plus 7 equals 4/5 times x plus 2.
Okay, so she got y plus 7 equals 4/5 times x plus 2. Thumbs up if you agree, thumbs down if you disagree. Why is it y plus 7 and x plus 2 when the point is negative 2, negative 7? Who can explain to me? Jen. Exactly. When we are subtracting a negative, so when I am subtracting negative 4 and subtracting negative 7 and subtracting negative 2, those become positive. So in our equation, it's written as y plus 7 and x plus 2. Easy enough? Okay, let's graph it. Guess what? Graphing is also pretty straightforward. So on number 4, 4 through 9, I give you an equation in point-slope form, and I want you to graph that line. We already have a point, and we have a slope, so do we have enough information to graph it? Yeah, so let's look at the point. In number 4, y minus 3 equals 1/2 times x minus 1. Let's write out what the point is first. The x-coordinate is what's attached to the x. So here it says x minus 1. What is the x-coordinate then going to be? Positive 1, comma. The y-coordinate is what is being subtracted from y. In this case, it says -3, so the y-coordinate is actually +3. And then I want you to circle the slope, which in this case is 1/2. So here's how we're going to graph them. We plot that point at 1, 3. And then from that point, we use the slope to find 2 more points. So what is the rise of this slope? 1. So from that point, we go up 1. What is the run? 2. So we go right 2. So here's my second point. I always want you to do 3 points, and we need to go in the opposite direction. So if I went up 1, the opposite direction would be down, and if I went right 2, the opposite direction would be left 2. So my third point would be here. I told you guys last week, that you do not have to show those lines. I just wanted you to show them so that I could see, or I just showed you so you could see what I was doing. Did I actually graph the line from what I have so far? No, I need to actually connect all of them, and we put what at the ends? Arrows, because they go on forever. I have shown you several graphs now, and on my graphs, the lines always extend all the way to the edges, and then I put arrows, so I expect yours to look the same. Not too bad? Let's do number 5 together, and then I'm going to have you guys do this on your own. We need to figure out what the point is first. So right now on number 5, write down what the point is. What's the given point? Dennis, help me out. What's the given point? Yep. Okay, Dennis said +4 is x, -2 is y. Thumbs up if you agree, thumbs down if you disagree. Nice and high so I can see. Good. Dennis, how did you get that y was -2?
Y minus y1, when you put two subtractions or negative signs together, it makes a positive.
Yeah, exactly. So he said because it's y plus 2, when you're subtracting a negative, that makes it positive. So the y-coordinate was negative. So we're going to plot the point at 4, -2. 1, 2, 3, 4, down 2. So your point should be right there. And ladies and gentlemen, I want you to circle the slope. Everybody shout it out for me. What is the slope? 3, which means I have a rise of 3 and a run of what? 1. So from my point, I would go up 3 and right 1, which would put me right here. And then I need to go the opposite direction. So I'm going to go down 3 and left 1, which puts me there. And then, as always, extend your line and put your arrows. That was a little of a dramatic extension, but that's okay. Okay? Everybody good? So what I want you to do is work on 6 through 9 for me. So here's what I got. I want you guys to check what you got against mine. Make sure that you agree. If you disagree, we need to figure it out. So let's double check what we did here. So let's actually write an equation of a line using 2 points. So for this example, we're going to use the points 1, 6, and -2, -3. So those are the points that are being used. Here are the steps. I want to find the slope first. So what do you guys think we're going to do to find the slope? Any ideas? We're not going to use slope-intercept form. We don't have enough information for that either. What? Slope formula. So we are going to use the slope formula to find the slope. Now, you guys should have the slope formula like memorized by now, right? y2 minus y1 over x2 minus x1. We're just going to plug numbers in. What do you guys want to use as x1, y1? And what do you want to use as x2, y2? Who has strong feelings about this? Jen? So the first pair is going to be the ones? Okay, so Jen made the decision for us. That's going to be x1, y1. And this one is going to be x2, y2. Okay? So when we plug it in, that means we're going to have negative 3 minus 6 over negative 2 minus 1. Guys, what's negative 3 minus 6? Negative 9. And what is negative 2 minus 1? Okay, does that reduce? Yes, to what? Positive 3. Good. So we have a slope, right? Now, is this similar to what we did in the previous examples? I have a slope, and I actually have 2 points to choose from. So what you're going to do is we are going to substitute the slope and the coordinates of 1 point. Into point slope form. Does it matter which coordinates you plug in? No. In fact, even though if I choose to use 1, 6, and Rose chooses to use negative 2, negative 3, even though our equations in point slope form look different, it's actually the exact same line, okay? So it does not matter, whatever you are more comfortable with. Who wants to plug in positive 1, positive 6? Who wants to plug in negative 2, negative 3? Okay, I think for sure positives win. So here's what we're going to do. An equation for the line and point slope form would be y minus 6 equals your slope, which is 3 times x minus 1. There you go. That's all you have to do. On your test or a quiz, if I ask you to write an equation in point slope form, I will have all possible answers, and as long as you give me one of those possible answers, you are correct. So you get to choose. It does not matter if you give me y minus 6 equals 3 times x minus 1, or you could have also done y plus 3 equals 3 times x plus 2. Either one is correct. I will accept both of these. Okay? Do you have to give me both? No. Just pick one. Okay? Now, point slope form is good, but slope-intercept form is actually the most used form of a line. So you are sometimes, not always, going to be asked to convert from point slope form to slope-intercept form. So we're just going to do that in the same problem here. So step 3, we are going to convert to slope-intercept form. By distributing and isolating y. Okay, watch. I'm going to use the y minus 6 since that's what we did. So I'm going to rewrite y minus 6 equals 3 times x minus 1. And I'm going to distribute 3 into the parentheses. So that's going to give me y minus 6 equals 3x minus what? 3. And I want to isolate y because slope-intercept form is y equals mx plus b. How am I going to get y by itself over here? Plus 6. So add 6 to both sides. So the slope-intercept form will be y equals 3x plus negative 3 plus 6 plus 3. Guess what? If we were to do that with the other version of the point slope form, we would end up with 3x plus 3. Okay? So converting back and forth, you just distribute and then add or subtract whatever is attached to the y. Notice my slope was 3, and I can see that here and here, right? The slope is still there. The only reason why slope-intercept form is the most commonly used is because it also gives us the y-intercept, which is just useful information to know. Okay? So what I'm going to have you guys do, you're going to do this exact same thing for problems 10, 11, and 12. I want you and your partner to work together to do problems 10, 11, and 12 for me. So you have your worked out example already. So I want you to check what you got on number 10. I showed my work for the slope, and then I plugged in the point 3, 5. So in point slope form, that's y minus 5 equals 2 times x minus 3. And then I distributed and added 5, and that gave me y equals 2x minus 1. In number 11, I got negative 1/2 as my slope, and I plugged in the point negative 6, 5. So that gave me y minus 5 equals negative 1/2 times x plus 6. When I distributed the negative 1/2, and then I added 5, I got y equals negative 1/2 x plus 2. Okay, so we should be okay on those? Okay, number 12 is the one that required a little bit, one extra step. I got a slope of 1/3, and then I plugged in the point 1, 2. So that gave me y minus 2 equals 1/3 times x minus 1. If you plugged in the other point, it's okay. You're still correct. And then what I did is I distributed. So I'm going to actually show you guys my work on that one. So I distributed the 1/3. And that gave me y minus 2 equals 1/3 x minus 1/3. Everybody good there? And then we have to add 2, right? But when I add 2, I need a common denominator. 2 over 1. What would my common denominator be? 3. So what do I need to multiply by to get a common denominator of 3? Good. Multiply by 3. Whoever said that. So times 3. So 2 over 1 is the same as what over 3? 6 over 3. So what I'm going to do, guys, is erase it right here just because I don't have the room. 6 over 3. So, ladies and gentlemen, what is 6 over 3 minus 1 over 3? 5 over 3. So that's going to be plus 5 over 3. So that's how I got plus 5 over 3. Okay? So negative 1/3 plus 6/3 gives you 5/3. So David asked, do we have to put it as an improper fraction? I for sure do not want this as 1.667. Do not give it to me as a decimal. And please do not give it to me as 1 2/3. Because 1/3 x plus 1 2/3, it's just not mathematically, when we're talking about graphs and lines, we like to keep everything in the improper fraction. And from here on out, guys, and for the rest of your math career, typically, I won't say always, but I would say like 95% of the time, you are going to want to leave it as an improper fraction. Okay? Decimals we really only like to use when we're talking about measurement and money. And then all the rest of the time, we want to leave it as an improper fraction. Okay? If you gave it to me as 1 2/3, I probably wouldn't take a ton of points off because we're now transitioning. But by the end of the year, I'm going to expect that that's what I see. On a multiple choice version of the test, this would be the only answer. It's not going to give you all of them. Does that make sense? But you need to be comfortable with that. So try practicing now. Okay? Okay. So how do we write an equation using the table? This table shows how much time it took to paint a room, I'm assuming, and the volume of the paint left in the bucket. So what do you notice as time goes on? It gets lower, right? The amount of paint left in the bucket goes down. So the time painting in days are your X's. The amount or the volume of the paint are your Y's. So how could we figure out the slope of this line if I were to graph it? What do you guys think? Do we have points that we can plug into the slope formula? Can you pick any 2 points you want?
Yes.
Heck yeah. If you want to pick 256, go ahead, and 344. If you want to pick 520, you can. You have actually 4 different combinations, 4 or 5 different combinations that you can use. You should get the same slope every time. Okay? I'm just going to go with the 2 smaller, these 2 numbers, but the top 2, but you can really do whichever you want. And then I'm going to do 56 minus 44 over, since I used 56 as my y2, which x do I have to use first? 2. So over 2 minus 3 equals. (56 minus 44 is 12 over -1. So what's my slope, guys? Good, -12. Oops. The problem wants us to give the equation in slope-intercept form. So what I'm going to do is I'm going to use point-slope form to get everything in there, and then I'm just going to convert to slope-intercept form. So I need a little bit more space. So right now I'm going to black out and give myself some more space. What point do you guys want to use? Who cares? Which one? 256. Okay, so we're going to use the point 256. So that's going to be y minus what? 56 equals -12 times x minus 2. Good. Okay, we have to convert to slope-intercept form. So I'm going to distribute the 12, or the -12. I apologize that I did not give you guys that much room. That's going to be -12x plus 24. And I need to get y by itself, so what am I going to do next? Add 56. Okay, guys, here's what I'm going to do. I'm going to black out 14, and then I'm just going to put my answer in the 14 spot. You don't do that because you still have to do number 14. So what is the equation in slope-intercept form? That's going to be y equals -12x. 24 plus 56 is going to give me 80. And then this last question is very, very important, and it will be asked of you several times. So I want to make sure that we all understand what's actually going on. What do the slope and y-intercept represent? And then I want you to underline this in the context of the situation. We have been asked this before, right? It means, what do those numbers mean in terms of the problem? The slope is negative 12, right? What does the slope mean? Okay, so it has to do with time passing and the volume, the amount of paint that's left, right? What does the negative mean? It's negative 12. It's going down. We call that a what? Slope is the same thing as what? It starts with an R.
Rise and run.
Not rise over run. Rate of change. So if my rate of change is negative 12, what does that mean? It's the rate that the amount of paint is doing what? Decreasing. So the slope is the rate that the paint is decreasing What's our measurement of time? Days, so each day. Okay, so it's your unit rate, right? What does the 80 mean? So it says that I'm decreasing by 12 gallons every day. What does the plus 80 mean? Melly? Exactly. The y-intercept is where x equals 0, right? So no days have passed. So 80 is the amount of paint that we started with. So the y-intercept is the amount of paint we started with. We, they, he, I don't know, whatever the problem says. Okay, another word for y-intercept is initial value. Okay, so how much should we start with? That's what slope and y-intercept mean, and specifically in terms of this problem. So what I want you guys to do before we go, we have 4 more minutes. I want you to work on problem 14. And then before you go, we're going to check our answer, and that's how you're going to get out of here today. Okay, so in this problem, we have the number of hours worked and the wages earned. The equation should have been 0.85 or 8.5x. No y-intercept. What does the slope represent? If I'm saying that for every 8.5x, what does that mean? What is that slope? What's 850? How much he makes it for each what? For each hour. Now there is no y-intercept. What does that mean? He starts at what?
0.
0. Which should make sense, right? If he's paid at an hourly rate, will he get paid anything for working 0 hours? Okay.